Thank you, David, so much for being with us this morning. I'm always inspired when I hear you speak, and I look forward to finding that algorithm that will help my children do their homework, not necessarily grade it. David also talked about expertise and experiments, and it's my pleasure now to introduce our next speaker, David X. No pressure, but coincidence, I think. Dave is the chief technologist of Red Hat's public sector organization. As the intersection between public sector customers and Red Hat engineering and product management, his customer interactions and domain expertise blend customer needs with industry trends to help Red Hat define open source computing in its enterprise. Dave has achieved Red Hat's highest level of certification and has received Red Hat's highest employee honor as a Red Hat Chairman Awards recipient. As a graduate of the University of Pittsburgh, Dave earned his undergraduate degree in computer science and an executive MBA from the Katz Graduate School of Business. He's an active member of Avicea DC and their Emerging Technologies Working Group, and he promotes open source and STEM at the Akron Linux User Group. Prior to joining Red Hat in 2007, he specialized in visual simulation, virtual reality, human-computer interfaces, and scientific virtualization at Silicon Graphics, Inc. Please join me in welcoming Dave X to the stage.
Yep. So good morning, everybody. So how many people have heard of Gartner's term bimodal IT? All right, cool, good number of folks. So I'll do a quick recap for those that aren't as familiar. So with, let's see, there we go. Yeah, so bimodal IT. So with bimodal IT, what happens is, what Gartner has done is that they've classified workloads into two major categories. You have, so bimodal IT, two categories. One is your mode 1, the other is your mode 2. Mode 1 is where you have your systems of record. These are the workloads that typically you've developed, for years, and they've been around for a long time. Probably running on a mainframe. They could be running on bare metal. They could be running on your virtualized infrastructure. And it was probably developed using waterfall techniques. So you can imagine whenever you do these big, massive deployments of your ERP systems or email systems, these are the types of things that you probably only update maybe once or twice a year because they're very big. If they go down, people will call you. And so these are the types of things that people are very, very sensitive about. And so compare that to mode 2 workloads. So mode 2 workloads, these are the new and up and coming workloads that people are doing. They're very stateless sort of workloads. Typically people, whenever they do the development of these mode 2 workloads, they're doing things like Agile or DevOps. And with Agile and DevOps, instead of doing 1 or 2 deployments a year, you may be doing a dozen deployments a day or a dozen deployments an hour. So it's a very different pace. It's a very different lifestyle for being able to do that. The other thing is that people have been developing the mode 2 applications using things like stateless workloads. So you can imagine instead of virtual machines that you know and love and you give them meaningful host names, you're actually standing up virtual machines that are stateless and disposable. If the machine dies, you delete it and you build a new one. It's identical. You add it to the load balancer and you move on. And the other thing too is that whenever people are developing these, it's on cloud workloads. It's very rarely on bare metal. And so one of the things that happens though is that with one of the things that Gartner talks about is there's a thing called the timid middle. So it's that dot in this little dip right here, okay? And that's one of the things that Gartner says that most people that are living the mode 1 lifestyle that want to go to mode 2, if they're going to fail, it typically fails in this timid middle. And that's where they're trying to move to mode 2, they're trying to do containerized workloads, they're trying to do these stateless workloads, but they're clinging to mode 1 methodologies of waterfall and those types of development methodologies. So that ends up being a problem. And so what I'm going to be talking about is mapping this to, as people move to the cloud, and you want to move to mode 2 workloads, what are the types of things that you want to be looking for as you make that move? So how do you close this gap? How do you prevent from falling into that ditch of the timid middle? So And if you guys want a copy of the slides, just shoot me an email, give me your business card, I'll send them to you. So if we think about this, along the top, that's your typical mode 1 lifestyle, right? Where you start off with your waterfall software development process, and then it ultimately ends up maybe on bare metal, maybe on virtualized infrastructure. Or you could move on to like your mode 2 workloads where you're doing things like Agile and DevOps, and it's moving out into the cloud, and it's very, very stateless. But one of the things that I challenge people with is that whenever you think about moving to cloud computing, I really see I really see cloud computing as being more of the where things like if you want to do DevOps and you want to move into mode 2, DevOps is really the how, and microservices and containers are the what. And so if you only focus on cloud computing and you really want to take advantage of getting those economies of scale and having, being able to do DevOps and things like that, and you're still doing the waterfall design, you're not going to, you could fall into that timid middle. And so you need to think about how you're doing the software development and not just solely fixate on using cloud computing technology. So what are some other things that people want to do whenever, to prevent you from falling into that rut of the timid middle? The first thing is look at open source software. So if you take a look at all the hot technologies that are coming out of Silicon Valley, it's all based on open source. This is a survey that was done by Black Duck Software, and I have a link in there that's really hard to read. But you'll see that a lot of the technologies that are coming out, it's predominantly done in open source. So you look at things like Docker, you look at things like Kubernetes, you look at the Mesos and Swarm and other types of technology. All that's done in the open source world. Very few of those things are done in the proprietary world. And so why do people embrace open source? Commercially, people tend to use open source in a commercially supported aspect too. So let's compare and contrast why people choose open source. So the first thing is interoperability. So how many times have you had like proprietary systems where you can't open the hood or you can't figure out ways to make one system talk to another system? With open source technology, you have the ability to do that yourself. Or you could work with a commercially supported vendor to provide those hooks for you. The other thing is when you think about interoperability and moving from mode 1 to mode 2 workloads, you could have Red Hat Enterprise Linux running on your mainframe on your mode 1 workload, but also have that running on your stateless cloud virtual machine that's running in AWS GovCloud. So you can have that consistency in both places. Another thing is security. So one of the things so there have been studies that have been done by DHS Host and Coverity, where they've done studies where they've compared proprietary software to open source software. And according to their studies, they were able to mathematically show that the products and the projects that they've examined, open source software has fewer bugs per 1,000 lines of code than proprietary. And that's because the code is available for everybody to look at. And that creates the incentive for people to do a quality job of writing the code because everybody's going to see it. People can't hide behind a binary if you're putting the code out there. And people can hide behind binaries if you're doing proprietary software. The other thing is access to the people that are writing the code too. Name your favorite proprietary software. You don't know who wrote it. Whereas I can look at open source code and I can look at the line of code and I can look in the Git repository and find the person that wrote that code. And I can contact that person, I could talk to that person. But the other thing too is that from a commercially supported standpoint, you could work with a vendor like Red Hat. And if you're having a problem with something or you need to get a feature, there's so many times that I've worked with many of our customers where they can actually trace back feature requests to actual lines of code in the products that we develop. And they take a lot of ownership in that and a lot of pride in that because they're able to affect change using open source technology that they wouldn't be able to do with proprietary. And then lastly, and tying all these things together is that this focuses, the ability with open source, David talked about this, is that one of the things that people often have is that just the ability of, you spend a lot of money just keeping the lights on. And if you're able to take a lot of that proprietary software or you're using commercially supported open source software and let somebody else do that for you, that frees you up to focus more on the mission and be able to innovate. So Mike from Cisco and Kevin from Red Hat are going to be talking a little bit later about some of the reasons why by us working together, Cisco and Red Hat, have been very successful with helping our customers than by us working independently. And here are some other things, like whenever you start looking at open source providers, certain things that you want to be looking at. Number one is how active they're participating in the ecosystem. So that means that you don't want somebody that just says, yeah, I'll support that code, but they're not actually writing the code, they're not committing to that code, they're just being a help desk for you. What you want to do is see people that are active committers in that thing, in that project, so that if you ever need to make a change or get a bug fix, they actually have the power to be able to do that. If you look at the Mode 2 technologies that are being developed, so things like Linux, containers, Docker, Kubernetes, those are things that Red Hat, we're either the number 1 or number 2 contributor in all of those projects. So if a customer comes to us and says, I really like this, but if only we had this change, it would be much more useful to us, we could actually affect that change where the customer doesn't have to write a line of code. The other thing is partners too, and so Mike and Kevin will be talking about this, where working together, it's by having things like Red Hat reference architectures and Cisco validated designs. Instead of you having to buy your own white box server, stand it up, and then you've created the snowflake that nobody else has ever deployed before, and you have a problem and you're stuck supporting it yourself. We have validated designs that actually are running in our facility. So if you call us with a problem, they're actually known and they're tested, and we could replicate the issues that you're having on the exact hardware that you have. And then lastly is customers too. We've been very successful. There are a lot of times, and I talked about this, where customers can point to lines of source code where they've affected change. I regularly bring a lot of our customers up to our engineering facility in Westford, Massachusetts for executive briefings. And it's really cool because a lot of times I would see our customers would be like, oh, I want a roadmap from Red Hat. And that's cool. It's like, we'll tell them where we're headed. But the thing that I always insist on is I want to hear a roadmap from the customer. I want to know what they're working on so that whenever I talk to them, I can present in ways that will resonate with them. And we could work together on the problems that they're having, and I can work with our engineering and business units to affect change to make those products work and be more useful to our customers. So wrapping up here, you want to be thinking again about as you have your Mode 1 workloads and then you want to move to Mode 2. I'm not saying to throw away everything that you're doing in Mode 1. Take a look at the things that work really well in Mode 1 and see where they can apply to Mode 2. So you standardized on Red Hat Enterprise Linux, you're using satellite server, you're using Red Hat Enterprise Virtualization, those types of technologies, and you're being very successful with those in Mode 1. They map really, really well to Mode 2. Because you could take RHEL that is running on your physical server or virtual server, move it to AWS and run it out on a public cloud, and be able to use tools like Satellite and CloudForms to be able to manage them all from one thing. And what that does, that builds what's called an open hybrid cloud. So that way I can have a choice of cloud providers. So whether I run it in my own cloud data center that I have on premise, or on AWS or some other community cloud or some other cloud vendor, I have that choice. As an end user. So I can move those workloads around. And lastly, what that does is by providing that bridge, that's what really allows you to take the successes that you've had with Mode 1 and be successful in Mode 2 and not fall into that trap of the timid middle and where the projects that you go after are likely to fail if you don't fully embrace the Mode 2 lifestyle. So with that, that's all I had, and I want to thank you guys for your time, and I look forward to talking to you later. Thank you.